Okay, in this session we're going to be talking about how to do some injection molding, and the two types of plastics we're going to be working with is high density polyethylene. We're going to use that on this machine on the left. Machine on the right, we're going to be using polystyrene. And so each machine has been set to the proper temperature and allowed to soak so the machine is ready. Now again, everything that's in this area right here is going to be hot, so we need to talk about safety. When we're loading and working with our dies and working in that area right there, we want to be wearing welding gloves so that we can actually, if we make contact, not get burnt, because that is about 430 degrees. Again, don't reach up there and just hold on to anything. So that's going to keep us from getting burnt. Now when we look at our dies, we have a set of dies, and we don't want to mix and match the die halves. We have two sets of Tensile dies that we're going to use for this lab starting off, and each die we want to handle carefully is going to come apart, and this is a complete set. So don't mix this die half with the other set because they may be off a little bit. These are a matched set. And so this is going to shoot two on. We're going to make two parts. We have our hole right here for our nozzle to go into the machine. It's going to line up with the dot that's right here. So if we put our die inside of here, again, you can open the clamp, slide it in. You want to push it up to the stop that's going to be on this side of the machine, and then come in here and tighten that up. Now again, we're tightening that up pretty snug because we have hydraulic pressure that we're going to be doing. We're going to be pushing down on this and coming down on that resin inside the melted chamber there, and we can shoot up to an ounce of material here, and it's going to come into a high pressure trying to separate those die halves. So this clamp is going to keep it together. If you don't have them seated up properly and clamped, you're going to get flashing at the parting line of the material. Now what I want to do is come in here and grab some material out of the bag that we're going to be using, and I'm going to use these little ceramic shot glasses right here just so that I can put my material in there. And if you can, don't make a big mess when you do this. Let's try and keep all the resin in the bag or into the machine and not all over the floor here. So I've got some resin. I'm going to come in here, and this is all new resin. I'm going to pour a shot glass in there, and the next thing I want to do is use a wood tool to help push the resin down into the machine. Now this is a first time we've used this machine, and there's not been any material in there, so we're going to have to kind of compact that material and get it to melt. And I'm going to kind of come down here and press a little bit, and then come back up and get more material in there. Now don't fill this bowl up here so full that it's overrunning. Just do about a cap full at a time, and then try and get what you have up there into the machine. Now I've got it pretty well loaded up, and I'm going to let that soak and heat that material up for a few minutes, about 3 minutes there. So all the material is now heated up where I can come in and press, and it's going to want to injection mold that part. So what I'm going to do is make sure that I didn't shoot a little plastic into the mold, which I did. I'm going to go ahead and clear that out. Again, you should be able to freely move that out with your hand. Don't ever take tools to try and pry the part out. If the part is stuck in the mold, let the TA or myself know, and we will help you guys out getting that out. So at this point, the mold is clear. I'm going to put it back into place, lining it up, tightening that up, and I'm going to come in here and smartly press down on this. You're going to have to put a lot of pressure, and I'm going to hold it, so that's my packing pressure, and I'm holding it in the mold, and then I'm going to be able to come off, and what we're going to do is let that mold sit there and cool that part down. While it's doing that, we can go back to the injection molding cycle here, and we can reload our machine with another shot of material. So I'm going to go ahead and get that material heating up as I'm letting the previous material in the mold cool down. So at this point, I'm going to come in here and go ahead and open this up and remove my mold out. And if you look, I now have a part that has been molded, and I have two pieces here. Again, this may be warm, so we're wearing our welding gloves, and that is one set. You're probably going to need to shoot a good set of parts for your labs because you're going to pull Tensile on there. So once you get a set, you're going to move over and shoot the polystyrene in that machine. Again, we don't want to mix and match the material and swapping out the molds. So this mold is going to be for the polyethylene, and this mold over here is going to be for the polystyrene. Okay, now that we've shot our part and it's the end of the day and we want to shut this machine down, what we have to do is a purge. And a purge is going to require us to use this little block right here that has a hole and it's an open area. What's going to happen is all the resin is going to go down and into this area. So we're going to slide this up into the machine where it's centered up here, and I'm going to just snug the vise up. I'm not going to put a lot of clamping pressure, just snug. That's taking all the loose play out. And then what I'm going to do is come in here, and I've pushed all the resin down into the nozzle, I've pushed all the resin into the barrel, and now what I'm going to do is just come in here and push down all the way down, full stroke, till I bottom out here, and I have pushed all the plasticized resin out into this chamber. Now if I look at this, I can see I have a lot of material right there inside. Now you don't want to touch that because this material at this point is very plasticized and melty. So if I pull this out here and get a spoon, I can show you this is basically melted plastic. Again, you need to be wearing gloves because it can burn you. Don't touch the material with the gloves as it will stick. You can see everything sticking. And so what we're going to do is let this cool off, and then I'll be able to pull this off my wood sticks and dispose of this. So what you want to do is you want to take your part from the runner system, and you're going to use these little snips, and you're going to come in here at the gate and you're going to remove the runner system so you just have your part there. That's going to allow us to go over and pull our tensile test. Now one of the things I wanted to point out is if you leave the material in the barrel too long at temperature, it can degrade the material and it's going to come out brown or burnt looking. So you want to get it to melt, shoot your part as fast as you can so that you get proper materials. You don't get any degradation due to heat in the sample. So we've molded our samples and we're ready to come in here and pull a tensile test on this. One of the first things that's going to happen is we've already done a tensile test on this machine, and we know that we can use the extensiometer down there, but it has a 2-inch gauge length. Again, our part does not have a 2-inch gauge length. So what we're going to use is the stroke provided from the data that's going to come from the encoder on the machine. So when we go to the Shimatsu on the computer and we want to load the method, you're going to load the tensile test method for the correct units, inches or metric units, and then you want to look at, and I think we have an EXT so we can actually see the stroke being captured there instead of the normal test method for using the extensiometer. So what I'm going to do is come in here and load my sample into the top templin grip first, and then into the bottom templin grip next. And again, you want to make sure that you have your samples where they are going to be loaded axially, so you don't have it being pulled off at an angle like this. You want to make sure it's completely vertical and centralized in the grips. So what I'm going to do is come in here and tighten this up, and it will close the gap on the grips. And again, come in and adjust that out where you can get it where it's perfectly straight up and down. And then I'm going to come down here, and as I close this down, I can tell that I need to lower the machine, so I'm going to put it in hand jog mode and jog it down there. Again, we're getting really close here, so you don't want to hit, but I'm going to come in here and then tighten up my sample on the templin grips there. Get that past snug. I now have my sample mounted. I'm going to take hand jog mode off. We're going to go to the computer and we're going to zero everything out and run our test. So we're at the computer and I've got the correct test method loaded up, and we've just loaded our sample in. So the first thing I'm going to have to do is zero out my force, my stroke, and that's the data that we're going to be collecting. I'm going to go ahead and zero out the extensiometer. So we should be seeing the stroke being recorded here and our force here, and this is an inch test that I'm running here. So what I'm ready to do at this point is come in here and hit start test, and it's letting me know I need to shut the door. So I'm going to shut the door and hit start test, and I should see my plot, so I can see that nice linear region coming off, and I'm going to be able to export this data out to my sample. Now I'm going to let this run for quite a ways, and once the test is done, we're going to go to file and export our data out as a common delimited file, a CSV file, so we can open that up and do data management and plot from Excel. Again, we've covered that in our tensile test video. If you need help doing that, go back to that video and watch that. I'm trying to keep the videos as short as we can, and we're just going to let this thing run on out. So I can already tell I probably hit my UTS up here. I'm going to see that the yield is a little bit harder to define on these plastics. Again, I may need to put a 0.2% offset, don't forget that, and compare the two. So hopefully that helps you out. We've covered how to injection mold our parts, and we've also learned how to come over and do our test, and we're going to capture the stroke data for our elongation portion, calculating our strain values.